So today we're going to learn how to identify and predict the products of a single replacement reaction. Okay. So for single replacement reactions, atoms of one element are going to replace the atoms of a second element that's in a compound. Okay. So I think the picture is probably like better than the word explanation. So you have atoms of this element, element A. It's going to swoop in here and take the spot of element B, and it's going to kind of boot element B out. Okay. So then A and C are now going to bond and make a compound, and then B gets booted all by itself. And then do you remember last week we kind of wrote just like the generic formulas for the reactions? So for this one, you could write A plus BC is going to yield AC plus B. Okay. And if it helps, so A is going to swoop in, it's going to take B's place, and it's going to boot B out, right? So A now bonds to C, B is by itself. So single replacement, because one element is just going to take the spot of its single different element. Okay, let me give you another analogy of how single replacement reactions work. Okay. My analogy is dancing. Okay. Who's some hunky, famous person everyone adores these days?
Michael B. Jordan.
Okay, so let's say you're dancing with Michael B. Jordan. Okay, here you are. You're dancing with Michael B. Jordan. Who's hunkier than Michael B. Jordan?
Nobody.
Give me second place then. Who's one step? Okay. You're dancing with Channing Tatum. Okay? You're having a really good time. But then Michael B. Jordan comes over and he's like, hey, can I steal this dance? What are you going to do?
Yes, of course.
Absolutely.
Of course.
So you go dance the night away with Michael B. Jordan and Channing Tatum gets booted all by himself. Okay. Okay, so now let me flip the roles. Let me reverse it. Okay. Let's say you start with Michael B. Jordan. He was the favorite.
Yeah.
Okay, let's say you start with Michael B. Jordan. And Channing Tatum's like, hey, can I cut in? What do you say? No, thanks. I'm good, right? Okay. So do atoms have brains?
No.
Okay. But do they have to trade places? Like, did you have to give up dancing with Michael B. Jordan if you don't want to? Okay. So same thing for atoms, except they don't have brains. So how they know if they're going to, like, swap their partner is something based on this activity series. So take a look at that chart I gave you. Okay. So here's the activity series of metals. Okay. So atoms don't have brains. They don't have these hunky muscles or whatever we're attracted to with Michael B. Jordan. Okay. But some are like more reactive than others. Okay. So the top of this list is the most reactive metal. You could think of lithium as the Michael B. Jordan of the elements. Okay. So lithium is the strongest. It can trade places with any of the other elements. Okay, so it'll like swoop in there and bond to that atom. Okay, as you go down the list, they get less and less reactive. Okay, lithium's at the very top. Okay, okay. So how the activity series works: if an atom wants to trade places with another atom, if it is higher on the table, then yes, it can trade places. Okay. If it is lower on the table than the other atom, then no, it can't trade places. Okay. So we're going to do a practice problem. Okay. So go ahead and write this first one down in your notes, and I'm just going to rewrite it. So we'll take magnesium plus zinc nitrate. Okay, so we have magnesium by itself. So magnesium wants to swoop in here. Do you think it wants to take zinc spot or nitrate spot? Okay, it wants to take zinc. The reason is they're both cations. Okay, so the cation wants to replace the cation. You could also think the metal wants to replace the metal. Okay, so this is where you're going to use that chart. Is magnesium higher than zinc on this table? Okay, so then yes, it can take its spot. Okay, so magnesium, it's going to swoop in here, it's going to steal zinc's spot, and it's going to boot zinc out. Okay. So magnesium's now going to bond to nitrate. Again, you have to do that crisscross rule to get the formula. So for magnesium, what's the charge? Okay. +2. And then what about for nitrate? Look at the back of your periodic table. Look at the back side. Okay, -1. So now that you have the charges, what's your next step?
Crisscross.
Okay, crisscross. So we get magnesium nitrate, which is going to be MgNO3 2. And then zinc is just all by itself at the end now. And then last step is just to check and see if it's balanced. How many magnesiums are on the left? How many on the right? Okay. How many zincs on the left? How many on the right? How many nitrates on the left? And how many on the right? Okay, are we balanced? Good. Let's take a look at the second one. So go ahead and copy the reactants down. So this time we have magnesium plus lithium nitrate. All right, so again, magnesium wants to swoop in and it wants to steal a spot. Does it want to replace lithium or nitrate? Okay, lithium. So you're going to use your chart. Is magnesium higher than lithium on the chart? Okay, no. So lithium, like it's not going to trade places. So when you have this scenario for products, you can just write NR for no reaction. And I'm going to say RXN for reaction. Okay, and then last, what about nonmetals? So in those previous two examples, I did metals replacing metals. So magnesium either wanted to replace lithium or it wanted to replace zinc. Okay, but what about nonmetals? So single replacement reactions, they can happen with nonmetals. However, they're limited to the halogens. Okay. And halogens, it's the second to last column on the periodic table, so like fluorine, chlorine, bromine, iodine. Okay. And take a look at your chart. On the right side of your chart, do you see nonmetals listed? Okay, so these are the only nonmetals you'll see, and it works the same way. So if it's higher up on the chart, then yes, it can trade places with anything below it. If it's lower on the chart, then no, it can't trade places with anything above it.